The main is the processing element module, where we have given how the base matrix elements have to be given.
Okay.
The main module is the systolic array module, which codes how the systolic array architecture have to be processed.
Okay.
Then there is a module where which is called as the SATB, which is for the test bench, as how the systolic array should work when any test cases is given. So these are the two inputs, A in and B in. I have given the matrix values. So in order to check this, if the output is correct or no, we have to run the behavioral simulation.
Okay.
So using these two A in and B in values, we will be able to check the output resultant as well. So here in the output behavior, as we can see, A in and B in are the two input values, which is 0D, 0E, 0F and 10, which is a hexadecimal pack for the A in matrix which we are giving. And B in is the 01, 02, 03, 04, which is a hexadecimal pack for the B in matrix.
Okay.
Both these two are 8-bit matrices, hexa pack, and the output resultant is a 16-bit, which is 000, D0.
Combination of A and B.
Yes.
Okay.
So here 008 and 004 are the matrix length and the bit length here, which we are doing. So next, this is the online simulation for the output. Now in order to get the hardware simulation, we need to configure the boards, the 7-segment displays. So here we have created the 7-segment display module as well, where we will be using all the 8 modules present in the Nexus board. We are giving these inputs here, saying for the first switch we will be giving the input, second switch we will be giving the B input, and since the output resultant is a 16-bit matrix, the thing is divided into 8-bit and 8-bit so that it will be displayed in the 7-segment display. So this is the code, and finally we have coded for each 7-segment display. Then the final module is the top module, which combines all of these modules into a single module. So this is like a calling module which calls the other modules. So here we have said for the first switch, the A input has to be called. For the second switch, the B input has to be called. And for the third and fourth switch, the resultant has to be displayed. If none of these switches are being present, by default I have to print this value, the blank display. So now configuring these, we will be getting the hardware output.
Yes.
So for this, we have to first initially run the synthesis, then run the simulation, and then finally do the bit stream generation.
Okay.